Hello, good morning. Good morning, everybody. This is Michael from coachapilot.com. So I am an ATPL instructor. I'm teaching principles of flight, meteorology, mass and balance, radio navigation, aircraft performance, plenty of subjects. You know me already. So here I put the direction of the website again, https://coachapilot.com. So you can contact me at any time if you need help for your ATPL studies, whether you are an ab initio student or a professional pilot who is converting his license. I will be happy to help you and to answer all your questions. So today I wanted to talk about a topic that I came across through last week with some students that apparently is generating some concerns for the students. So it's a classical question of principles of flight that talks about the load factor that you experience when you are flying into vertical gusts. Okay, so what's the point here? This is the question that I'm talking about. An aeroplane maintains straight and level flight at a speed of 1.8 vstall. A vertical gust causes a load factor of 1.9. Determine the load factor that would be caused by the same gust at a speed of 2 Vs. Okay, so plenty of time the students have difficulties to answer this question. So I will show you that it's extremely simple and it can be solved in, let's say, less than 15 seconds. Okay, how does it work? What is the principle? The principle is that, first of all, we fly at a load factor of 1. So because the question says that the aircraft flies straight and level. So it means that literally we can assume that the lift equals the weight and our load factor equals 1. Okay, and from that, we refer to the gust load diagram in which we represent the load factor as a function of the speed, like that. And we demonstrate that for a given gust of constant intensity, a vertical gust here, that would obviously increase the angle of attack. Okay, like that, and that would obviously increase the lift. Obviously, the load factor would not be 1 again, it would increase. Okay, so we demonstrate that the increase of load factor, and I insist on that the increase of load factor is proportional to the speed, exactly proportional to the speed. Okay, so let's come back to the question. The question says that we are flying at 1.8 vstall and we experience a vertical gust that causes a load factor of 0.9. Okay, so assuming that we were flying straight and level, initially the load factor was 1. So we have just an increase of 0.09 that corresponds to this gust experienced at a speed of 1.8 vstall. Okay, so then we can just draw simply a table that represents the speed at which we are flying, that was 1.8 vstall, and the increase of load factor. Increase of load factor. Okay, so if the load factor is, let me check again, 1.9, actually the increase is only plus 0.9. Okay, because the new load factor will be 1.9. All right, so then the question asks about the effect of the same gust that would be experienced at a speed of 2 vstall. So here we have 2 vstall. So then it's just a proportional calculation of increase of load factor. So how do you do that? You take the initial value of plus 0.9, you multiply it by 2, and then you divide it by 1.08. So we have 0.9 times 2 divided by 1.8, is equal to 1.8 divided by 1.8 is equal to 1. So that 1 is the increase of load factor. So the load factor will increase by 1. Okay, so if initially the load factor was 1, because we were flying straight and level, obviously the new load factor is the initial load factor 1 plus 1. Okay, so the new load factor will be 2. And that's it. Problem solved. Here it is. Okay, new load factor equals 2. Okay, so what is relevant in the question is to understand that what is proportional to the speed is not the load factor itself, but it's the increase of load factor. Okay, the increase of load factor for a gust of a constant speed will be proportional to the speed of the aircraft. All right, here it is. I put it again on the board, so just if you want to take it, feel free. And that's it, as simple as that. So it took, to calculate this proportional calculation, maybe 15, 20 seconds, something like that. Okay, so I hope that it's useful. And I hope that I can help you in your ATPL studies. And here it is. Enjoy ATPL. All the best. Thank you very much for watching. Ciao.